Hey everybody, I'm David and I'm going to go over polynomials and then specifics about some polynomials that I think are really important for just about all of high school math and beyond. Okay, if you look at the polynomial that's drawn over here, we have x-intercepts. X-intercepts, I'll just label them by comma list. I'll just comma separate them to list them, excuse me. Looks like we got -5, -3, and a 1. So those are those x-intercepts. If you understand how factored form creates those x-intercepts, you might be able to work backwards. You might be able to guess that this polynomial may have binomials that created those x-intercepts. Because if I have a binomial of x plus 5, x plus 3, and x minus 1, then you could see the what makes 0 question. And what I'm asking there is, what x value makes 0 out of each of the binomials? And those answers are the x-intercepts. Why? Because when you ask my favorite question, what makes 0? We want to know when this output is 0. And if you notice, every one of the outputs here is 0. So when I ask what makes 0, I'm asking, what is the x-coordinate where y is 0? And that's why it works. You could write them as separate little problems. X plus 5 equals 0. X plus 3 equals 0. X minus 1 equals 0. You can do all those little extra problems, and most textbooks would have you do that. I'm teaching high schoolers. You guys can play with numbers. Take a chance. Guess and check a little. What makes 0? -5, -3, and 1. Cool? All right, let's try some. Here's a polynomial. What makes 0? What makes 0? Let's start on the right side. It's a little bit easier. I think, oh yeah, if x equals 2, that makes 0. Huh. Over here, can I just take the opposite of that number? Yeah, I think that works right now. Let's try that. I'll guess -6. And if I mentally plug it in, yes, that works. How about over here? Is x equal 3 going to make 0? That's opposite of -3. If I was to plug that in, I would, not get 0. This is a two-stepper. Now, if you can hold a couple numbers in your head and make a fraction, you don't need a calculator. You may not even have to write this down. If you see it as 2 actions that need to be undone, plus 3, divide by 2, you might build a fraction in your head and get the last answer. And these are all x-intercepts. Where are the x-intercepts at? Well, there's 1 at, here's y, here's x. Let's see, there's 1 at 2. There's 1 way over there at -6, and there's 1 at 3/2. That's 1.5, in case you're curious. But 3/2. Leave it in fraction form. As long as it's reduced, as long as it's simplified fraction, it's a nice way to go. So each one of these graphs has something in common. They've got an intersection. They've got an intersection that is the same. Real quickly, if I do what makes 0, I'm going to get x-intercepts at 2 and -3. I'm going to get x-intercepts at 0 and -3. And even with this line, yeah, that's a line. That's crosses at 3, goes up 1 over 1. I can draw that. Yep. That's an mx plus b. I can draw that. I'm sure you probably have a memory of mx plus b. And you know what? What makes 0 is x-intercept, -3. And look down here. If you look at the graph, sure enough. Now, what's common here? What do all of these graphs do? If I was to graph all of them on one giant XY grid, right? I would have one of the graphs hitting 2 and -3. I would have another graph having x-intercepts at 0 and -3. And down there, we already realized that that graph has one at -3. So whatever these graphs look like, they have one dot in common. They have one intersection in common. And that's at -3. That's your -3. So when they say, hey, what's the solution to all of these? What answer makes them all true? You would say -3, 0 would make these all true. That's the key. That's the key to this. So this is the idea of intersections are solutions. Just real quick, okay, that first one that had -3 and 2 made a parabola. It probably looks something like this. The green one also made a parabola, something like this. And the line and the linear went through, as we saw, just like this. And guess what? All of them hit the same exact XY point. That's what it means to be a solution. That's what it means to be an intersection. Good luck with homework.